Alright, in this video we're going to talk about arc length of circles, and different parts of arcs on a circle. Okay, so arc length, we're going to think of arc length as the pizza crust on a pizza. So if you actually think about a pizza, pizza is a circle. Nice giant pizza. Okay, so if we're looking at a pizza, here's our pizza, and the pizza is cut up into a bunch of different slices. Okay, let's do it one more time. So let's say that there's 8 pizza slices on your pizza. Okay, so if it's cut up into 8 pizza slices, each piece has just part of the crust. Right? The crust actually goes all the way around the pizza, but only part of it is on your one piece of pizza. So this, on the end, I'll use a highlighter, is this part right here, the crust, is what we call the arc of a circle, right? An arc. If we're trying to find the length of an arc, we're trying to find how long this piece actually is. So in feet or inches or yards or miles or whatever it is, the actual length. So how do we do this? Well, the outside of the circle is called the circumference. And if you're finding just part of this, it's just part of the circumference. Well, in order to do this, we need to remember what is circumference. So circumference is the outside of the circle, and the equation is either 2 pi or r, or there is another one, pi times diameter. Either one works, it's the exact same thing. So let's look. We're actually going to do one of each. This one we're going to say 2 pi r, and this one we're going to say pi times diameter. So on this one, the radius is 8. 2 times pi times 8. 8 times 2 is 16. Leave our pi. We get 16 pi. And this is in terms of pi. Second one, number 2. We have pi times diameter. Diameter is 12. So we get 12 times pi, which is 12 pi. So these are fairly simple. And that's, again, the outside of the circumference of the circle. So if you remember how to find circumference, let's look into, well, arc length. Again, arc length is just part of the circumference, just a piece. So if we highlight this part right here, we just want to find how long this piece is. If we're thinking about this, well, if it's part of the whole circumference, it's going to be like a ratio. Okay, so we're going to say arc length, the arc length, this part right here, the green part, out of the entire circumference. So this is our ratio. Part of the arc out of, or the arc out of the entire circle, which we called circumference. Okay, well, we need to set this equal to something else, so some other ratio. Well, if we have, let's say, a central angle, kind of like a piece of pizza again, and again we're trying to find the crust. Well, we have how many degrees all the way around the circle? The circle is 360 degrees. So if our piece of pizza, this little piece, a slice, is, let's say, let's just make up a number, how about 70 degrees? Well, that means we have 70 out of the full 360. So what we're going to say is it's equal to the degree measure, the angle of our piece of pizza, this piece right here, or the angle of the arc, divided by 360, which is, again, the whole thing. Okay, so you can set up a equation just like this, or a proportion, and then you can just plug in each piece, and then you can cross multiply. But I'm going to write it a slightly different way. Okay, so I'm going to write degree measure as dm over 360, which is equal to arc length. Let's use green. This is circumference. Let's call it C. What color am I missing? I guess black. So arc length, I'll call it AL, arc length. So I'm going to actually cross multiply just like this with all these numbers, or the letters still right here. So degree measure times circumference. Okay, so we get degree measure times circumference. Again, we're cross multiplying, is equal to 360 times our arc length. Well, again, we're trying to find our arc length, right? So how do you get rid of 360? Well, we need to divide by 360 on both sides. So these cancel, so we end up getting arc length is equal to our degree measure, I'm actually write the whole word, degree measure, divided by 360. This is being multiplied by our circumference up here. Okay, circumference. Okay, so this is our equation. I have it nice and written out right here. So arc length formula is, we're going to use degree measure divided by 360 times the circumference, and this is equal to the arc length. Okay, and that's where it comes from. It comes from this proportion right here because it's just part of the circle. Okay, so proportion. You can leave it again in proportion. You can solve it just like that, or use this formula. And this is what I'm going to use today. Okay, so let's see some examples. What do we mean by all this? Well, this is an example. We have a circle. I want to find first the measure of arc AB, and then we're going to find the length of AB. So if we remember, the measure is the degree measure of the arc. Okay, degree measure of the arc. If we're looking for AB, this is a central angle, and a central angle is equal to 100. That means the arc is equal to 100 because it's always the same as a central angle. So 100 degrees. Okay. The length, remember, we have an equation. So I'm going to click right here. The formula pops up. So degree measure divided by 360 times the circumference, and this is what the formula we're going to use for. So again, the degree measure of our angle, the measure of our arc is 100 degrees. Divide by 360. We're going to multiply by our circumference. And again, what is circumference? Circumference is pi times diameter, or 2 pi r. So I'm going to use pi times diameter. This is the radius, 6. How do you find the radius, or how do you find the diameter from the radius? You just multiply it by 2. So if the radius is 6, that means the diameter is 12. Plug that in. 12 times pi. So we can divide these and multiply by 12 pi. So we end up saying 100 divided by 360 multiplied by, I'm just going to multiply by the number 12. And I'm going to leave it in terms of pi, so we get 3.3 pi. Okay, and this is our length, our arc length of the arc AB. Next problem. Again, this is a circle. Here's our arc CD, the measure. Well, if the central angle is 24, that means that the arc is also 24 degrees. How do you find the arc length? Use this formula. So we're going to say degree measure, 24 divided by 360 multiplied by circumference. And remember, circumference is, I'm actually going to use the other one, 2 pi r this time. Why not? The radius in this case is 10. So 2 times pi times 10. 2 times 10 is 20. We'll leave it in terms of pi, so we get 20 pi. 24 divided by 360 multiplied by just 20. We'll leave it in terms of pi again. We end up with 1.3 pi. And again, this is our arc length. Another example. This one's a little interesting. Okay, first we want to find the measure of the arc JVH. J to V to H. Okay, we're going to assume that JH is a diameter, meaning that JVH is going to be a semicircle or half circle. If it's a semicircle, that means that the degree measure is 180 degrees. It's half a circle. If the whole circle is 360 divided by 2, we get 180. So we have 180 degrees as our degree measure. So our formula, degree measure divided by 360 times circumference. Degree measure is 180. We divide by 360. That was pretty bad. 360. And we multiply by the circumference. The circumference is equal to pi times diameter. In this case, the diameter is 30. So pi times 30, which is 30 pi. we can go ahead and multiply these together. First, 180 divided by 360, and then you multiply that by 30. Again, we'll leave in terms of pi. We get 15 pi. Okay. And the last example. So in this case, it says find the length of each indicated arc for each circle. Leave your answer in terms of pi. So again, find the length of each indicated arc. So how do you find the length of an arc? There's a formula, degree measure divided by 360 times the circumference. Okay, so the degree measure. Let's look first at the arc TC. There's actually two we're looking for, so let's find TC. TC is, I'll even highlight it. Let's get this blue color. TC, that arc right there. Okay, so let's find the length of arc TC. So the degree measure is, again, this is central angle, means the arc is exactly the same, so it's also 128. So degree measure is 128 degrees. We divide it by 360, and we multiply by the circumference. The circumference is pi times diameter. Our diameter in this case, well, we know that from the center point P to the point D on the circle, P to D is 3, and that's what we call the radius. If the radius is 3, that means the diameter is twice as much, which is 6. 6 times pi is 6 pi. So we end up getting 128 divided by 360, multiply that by 6, leave in terms of pi, and we get 2.13 pi. And the arc BTC, we have, I'm going to try and find a space to put this. Let's start right in here. BTC. Okay, we have a degree measure of, well, BTC. From B to T, all the way back around to C. So in order to find this, we need to know what arc BT is also. We know what TC is, it's 128, but what is arc BT? Well, if you look at the central angle, it's a 90-degree angle, meaning that the arc is also 90 degrees. So we want these two combined, B to T to C. So 128 plus 90, I guess I can write that down, 128 plus 90, and we get 218. So our degree measure is 218. We're going to divide that by 360, and whoops, I used the wrong color, oh well. And the circumference, it's the same exact circumference as last time because the circle didn't change, so it's 6 pi. So we say 218 divided by 360 multiplied by 6, and we end up getting 3.63 pi. Again, this is in terms of pi. Okay, well this is over arc length. Good luck.